Let's pretend nothing happened. Hello, everyone, and welcome to this presentation. So today I will talk about JavaE 7 interceptors, and I want to say two things about it. First of all, it's a presentation I did with Marina Vatkina during JavaOne. Unfortunately, she couldn't come here at Devox, so I actually took the whole part of the presentation. So there might be some questions I might not be able to answer you, but don't worry. Worst case, I will just take the question down and we'll find a solution. The other thing is, I don't know who is native English, but nuts and bolts is not necessarily super non-native English friendly. It basically means the basics of JavaE interceptors, what's underneath and what we are doing with it. There is also another meaning that you can find in, what's the name of that? It's Urban Dictionary, but I won't mention anything about that. So what we are going to cover today is basically give you a super quick overview of what interceptors do in JavaE 7, and then we will jump right into what has changed, what has been added to Interceptor 1.2, which is part of JavaE 7. And that is why I actually have done the presentation with Marina is bin validation, which I am the spec lead of, is actually a heavy user of the new features of Interceptor. Actually, we did ask explicitly for new features. So what I will show you is a two-step process where I first explain to you why bin validation needed those features. And then, so you could understand the use case, for example, in your application and extend it from there. And then we will dive into each of the features and give you a quick overview, I mean, a long, detailed overview of each of the features and the tiny little details. We will also talk about JTA declarative transactions, which is a bit outside the scope of what I will talk about right before. So first of all, I don't know if you can see it on screen, but I've got a mustache, and actually I don't do that on a daily basis. Actually, my wife asks me to shave when I come back from Devox, but I do it to really raise awareness, thanks through the Movember event. It's basically awareness around men health issue, prostate cancer or any kind of other man-related cancer, depressions and things like that. So go see your doctor regularly. It takes you 2 hours. It might save your life, basically. And if you want to give some money to these guys, please do. But the man behind the mustache is actually me, Emmanuel. I work for Red Hat. I'm a data platform architect for them. What it means is I really cover everything related to the data middleware solutions we do these days. In practice, I come from the Hibernate land. I've been working on JPA and then Hibernate Search, Hibernate Validator, and the latest baby is Hibernate OGM, which stores data into NoSQL data stores instead of relational databases. But I also have my hand in InfiniSpan and the latest language from the community, and Red Hat being heavily involved in that is Ceylon. We just released the 1.0 yesterday, so have a look at it. It's ceylon-lang.org. I'm also partly involved in specifications, especially around the JCP. So I'm the spec lead of bin validation, and I did lead 1.0 and 1.1. I'm also part of the JPA expert group, and I'm giving a hand for JavaE 7, 8, 6, whatever, in general. I don't know who was at the Java Posse, but I'm not officially part of the Java Posse podcast, but I do have other podcasts. One of them is about JBoss. It's called JBoss Community Asylum, where we talk about the projects that are actually used in our product to actually make the great technology. I could mention Fuse, I could mention ASCII Doctor and Ostruct that we use to build some of the new websites we've been doing. I also could mention the fact that we had a lawyer and interviewed this guy for an hour, and it was actually fun and very, I learned a lot from that. So if you're an open source user or even an open source contributor, go listen to this episode. It's really good. And if you speak French, I don't know who speaks French. Wow. Well, more than I expected. But anyway, you should listen to Les Cascadeurs, which is a French podcast. And if you don't understand French, you should first understand French and then listen to it. All right, back to our subject. Let's discuss interceptor. What is interceptor? It's obviously the kind of technology that lets you intercept a method call and do some stuff before actually executing the method, right? And in previous version of Java EE, this was kind of part of the EJB specification, and then other specification had some kind of interception technology. So everyone was sort of reinventing the wheel. So what they did is, what we did actually is extract the notion of interceptor into a dedicated spec, so interceptor 1.1, 1.2, and bring all the knowledge in one place, right? So all the rules about Java EE interceptor, how they are activated, in which order, etc., are actually expressed in one place, which is much easier to read for you. And interestingly enough, the specification is actually used by you as an application developer, but also by frameworks that integrate into Java EE and want to do some, magic stuff. Even the platform actually use interceptor. Bin validation does use interceptors to do a lot of things, and we will discuss that in a minute. So what is specifically new about Interceptor 1.2? First of all, the specification document A has been centralized and has improved a lot. We'll talk about that in a minute. But we added a new lifecycle interceptor, the ability to intercept the constructor execution. So you could actually intercept methods and do stuff after the constructor with a post-construct event and the pre-destroy event or right before the component is destroyed. But you couldn't intercept and do stuff around the constructor, when the constructor is actually executed. Bin validation needed it, so we added it to the standard. The other thing we needed is a way to globally define the ordering of one interceptor compared to another. If you, as an application developer, writes the interceptor, it's sort of easy because you can define it at the application level. But if we want to define it at the platform level, it's a bit harder because we could do it under the hood and say, hey, that's going to be that way, or we could define a generic model that could be reused by everyone, or the frameworks, and so on. And finally, we simplified rules around how you write interceptor methods. We'll talk about that during the end of the presentation. But one of the, it's not very sexy, but one of the work that Marina has done is really to take all of the interceptor technologies and put them in one document, make it actually readable, reflow the document, add examples, and so on. So no, it's easy to see interceptors as actually one, unified element in the platform. So stuff that were specific to CDI moved back, stuff that were from EJB actually got extracted, and the specific things about EJB or the specific things about CDI actually stayed in their respective specifications. All right, so why did bin validation need interceptor? Before I explain that, I will explain to you, briefly what bin validation is about. So bin validation is a JSR, it's a standard. It's part of Java EE 6 and 7, but it's also working in Java AC. You can use it in any of your application. And the goal is to have you define and declare constraints on your objects. So on the getters or the fields of your object, you can apply some constraint. You say, in this example, you say that the first name should not be null and the size is limited to 100 characters. The second example shows the extensibility of the framework. Not only we do provide some base level constraints, but you can also write your own constraints. In this case, we write a social security number validation, which might be different between different countries, right? The nice stuff I like about the fact we use annotation to express constraint is that when you look at this code, you totally understand what's going on. This is a social security number, and the string is more constrained than just any kind of string in Java. The second benefit of being a standard is, A, there is an engine that other frameworks or platform can, or even you as an application developer can reuse, and the API is standardized. So the ultimate goal of that is to say, when a framework or a JSR has a natural life cycle where validation of the data makes sense, they should go and call bin validation, and the objects that are used by, during this life cycle will be validated. If something is wrong, we raise some kind of error report that is totally adapted to the environment. Let me give you two examples. JPA, when we save an entity, when we update an entity, and potentially when we delete an entity, what we do is we go and execute bin validation, of course, if the object is actually constrained. So you don't have to manually call it from your application, even though you can, right? It's totally doable, but the ultimate goal is for you not to even have to do that. The second example is JSF, so the web layer. There is a binding between a form input and a property in your object, in your domain model. What JSF does is ask bin validation to validate this specific property with the value you provided from the input field. We validate it, and if something is fine, great. If it's not fine, we provide an error report to the user. And it's not limited to Java EE. Bin validation can run anywhere in Java SE, so a lot of frameworks actually do use bin validation. So you express your constraint in your objects, and then all those frameworks actually make use of it. A couple of examples, Tapestry, GWT as an implementation of bin validation inside, on the client side. Any modern, Stripes, all those frameworks actually have an integration. So in bin validation 1.1, what we wanted to do is to try and see if we could go a bit beyond that and not only validate getters and properties at a very specific time, but also validate method parameters and return values, potentially, when a given method is actually called. This is an example where we have a CDI bin. It's using the request scope. And what I've declared here it's probably obvious to all of us in the room, is the parameter age should be at least above 18, right? 18 or above, right? And the return value, the list of user, it could be empty, but it cannot be null according to this description. So our goal really, from a bin validation point of view, is to let you express constraint on the parameters and the return value, and voila. If the parameter is actually invalid, we raise some kind of exception. Except we didn't want to write an interception technology, right? We rather have focus on other constraint-related features. So what we did is look at what kind of interception technology we had at the Java EE level, and that was the Java EE interceptors. So what is happening from a client point of view is you're calling a method, and technically some kind of interception technology is triggered. We have an interceptor implementation that is related to bin validation. We look at the parameters. We execute the validate parameters method of bin validation. If everything is fine and there is no constraint violation, good. We go and execute the method. If one or more of the parameters are actually invalid, what we do is create a constraint violation exception and raise an exception. Okay? So let's say the parameters are valid. So we go and execute the method. The method potentially returns a value. We validate the value if there is a constraint on it. And if the value is invalid, we raise an exception. If it's valid, then that's fine. The client didn't see that we actually did some kind of validation for him. So we need some kind of interception technology. So what bin validation focused on is the semantic of how this stuff should happen and what are the rules. But bin validation as a spec or as a product, I guess, does not implement it. What we relied on is other interception technology to implement that stuff. In particular, we use CDI portable extensions. So when we looked at the example right above here, literally when CDI starts, we look at the bins, and if the bins have constraint method with @NotNull or @SSN or some specific annotation related to constraints, Then we artificially add an interceptor to it via an interceptor binding. We'll talk about that a bit later. Because our goal as a bin validation spec was really to be able to be reused on any platform, not just Java EE, right? So Spring could use us, Play could use us, I don't know, whatever, JRuby could use us, anything, right? So that there is something that is standard at the Java level and not just this Java EE ecosystem. Of course, it works right in Java EE, and we spent a lot of time to work on that. But interceptor as it was, wasn't enough. We were missing a couple of things. So we came and discussed with the CDI expert group, and because the interceptor technology was moving into another group, we also talked with the interceptor expert group, EJB, and of course Java EE at the umbrella level. So even if what I'm the only one presenting here, there's been a lot of effort from a lot of different companies and people to make it a unified technology. So one thing that was missing is intercepting constructors. You could intercept methods, but you could not intercept constructors. So we added an @AroundConstruct and the semantic that goes with that. We'll discuss that a bit later. But basically, if you think about it, how do you intercept a constructor? Well, right before calling the constructor, you call the interceptor. The interceptor then delegates to the next interceptor, and the last in the stack actually creates the new instance, some object. The new instance is provided back, and the interceptor stack is executed back, and then you got the new instance. The other problem we had is we had strong feelings, I guess, about when validation should happen during the interception stack. If you think about it, we don't want to apply some, I guess, business-related rules before the security has been applied, or potentially the validation logic actually involves some kind of resource within a transaction. So we have to be after the transaction, right? So we want it to be as late as possible in the interception stack. We could have said, hey, by the rule of God of Java EE, we're going to be last. Instead, we decided to introduce the concept of global priority inside interceptor, so you could also use that. And we will use the @priority annotation, which literally declares a number, and that number being the lowest it is, the earliest you are in the interception stack. The biggest it is, the latest you are. And we have defined some ranges so you can really target when your interceptor wants to be applied. We tried a more elegant solution saying, hey, bin validation interceptor should happen after the transaction and security, but it was quite complex to express and very verbose. So and plus the algorithm to resolve those kind of rules, and getting an order from a set of partial rules can be quite hairy. So we decided to go for the simple approach that I think will work good enough. So just for the record, we are at platform after plus 800. We'll talk about that a bit later. So if I put that back together, bin validation provides the API to validate parameters, validate return values, and so on. CDI portable extension add the actual interception technology to the CDI bins, and the interception technology lets us intercept constructors and methods, and also define the priority. When are we going to be executed as an interceptor? And the cool stuff really is the spec is, there is a generic chapter that says how it should happen, and a subsection of that chapter is about Java EE specifically, right? So Spring or whatever the platform you guys like in the Java universe, can actually implement the generic part of it. So that's it about the use case, the reason for those new features. Now let's dive and detail why why we have those. How those new features are actually. The semantic of them and how you can use them. The first one, remember, is AroundConstruct. The goal is to have a new lifecycle callback, which is about intercepting constructors. Nice. There is a limitation compared to around invoke, compared to a method interceptor. Method interceptor potentially can be on the actual component you're intercepting. So there might be a specific method on the component that says, call me and intercept all the methods of that component. You cannot do that when you intercept a constructor because you don't have the actual instance yet. You're about to construct it, right? So to the place where you need to put the actual AroundConstruct code is in a specific class that will be a dedicated interceptor class. In practice, it's a good idea anyway to separate them, so I don't see it as a limit. I just mention it here as just a logic constraint to the concept. So what is the workflow? The workflow is we're about to create a new component instance. So we create the interceptor instance. Then if this interceptor uses @inject or has any kind of injection point, we resolve them and populate the injection. If the constructor actually uses injection to populate the parameters, we resolve that. If the parameters are actually provided by the user, fine. Once we have those parameters, we actually call the interceptor, or more likely the stack of interceptors. And an interceptor is really a method that receives this invocation context object, do some stuff before, call proceed that says go call the next guy, and do some stuff after potentially, and then return the value, okay? So proceed literally says go call the next interceptor in the stack, and the last interceptor in the stack is actually going to create the new target, the instance of the component. So you cannot access the target instance before you call proceed in your interceptor, but you can after by calling the invocation context.getTarget. Finally, we step back from the interceptor stack and we're done, and the instance is ready and instantiated. We resolve the injection of the component, so @inject and stuff like that. And after that, we go and call the post-construct lifecycle method, if there is any. So the big difference between AroundConstruct and post-construct is AroundConstruct is right before and right after the instance is created, which means you will not get the component instance does not have its injection points resolved, so you cannot call them or do anything with them. You can do it in a post-construct. So it's a good trick to know. So how does it look like? In this case, I use interceptor binding, which I personally find more elegant. So what we have here is an annotation, that does express the fact that I'm going to intercept a given thing with a given interceptor. Okay, so interceptor binding here is the validate constructor annotation. And this annotation is actually used along with the @interceptor annotation to express that a specific class is actually an interceptor that contains potentially AroundConstruct or AroundInvoke or all of those annotated methods. Okay? Simple enough, right? If you're a bit familiar with interceptors, just like AroundInvoke, it's just AroundConstruct. And when you want to actually intercept something, you put this interceptor binding annotation to whatever you want to be intercepted. It could be at the class level to intercept everything. It could be at the constructor level to be just the constructor or the method. Okay? So that's it about AroundConstruct. Let's now focus about the global @priority. So remember, our objective was to be able to express ordering between JavaE platform interceptor in a portable way. So what we did is to add the notion of @priority on a given interceptor. The smaller priority meaning it's called before, earlier in the stack, and the bigger the priority, the later it is called in the stack. Of course, if two interceptors have actually the same priority number, we pick and choose randomly which one we want to execute. Okay? And it only works in the case you use an actual interceptor binding annotation, like this one. Validate constructor is actually an interceptor binding annotation, and that's when we let you define the ordering via the @priority annotation. If you explicitly order the interceptors via the add interceptors annotation that I will go into detail a bit later, then we ignore that. So what are the priority ranges I was talking about? Think about it. So we've got three types of interceptors: the platform level interceptors, like the JavaE God level interceptor; the library interceptors, like library extensions of JavaE that want to do some stuff; and the application level interceptors. So in some ways, we want to sometimes to do stuff before the application and sometimes to do stuff after the application has intercepted things. So what we define is literally a few ranges. One is the platform should go, the early interceptors of the platform should be between platform before and library before. If you have a library that extends JavaE, go between library before and application. Application, do anything between application and library after. If you want to do something late as a library, you do library after between library after and platform after. And like bin validation, when you want to be as late as possible, you take platform after, and we added 800, right? Which is almost to the, it's 1,000 kind of ranges jumps. So we went almost at the end, but we left rooms for other people if there is a need to. It's not actually enforced, so if you as an application developer writes priority of level 5, you will be executed very, very early on. It's just recommendations here. So how does it work in practice? Remember the actual interceptor class, you simply add an add priority annotation to it. And you can use one of those ranges boundaries and add values. In this case, I want the validation to be very, very early on. So I say library before plus 10 points. The second piece of code is exactly equivalent. I just find it less readable, so I'd recommend you do the first part. It provides way more semantic to the people, the team that will read your code down the road. So priority is one way to order interceptors when they are using interceptor binding and the binding with interceptor binding annotations. The other approach you can use and have been able to use for a long time is the notion of add interceptors, which is literally a list of classes that corresponds to the interceptors you want to execute. And because it's a list, it's ordered. So in this case, when I call method 1, interceptor A is actually executed before interceptor B. If I call method 2, interceptor A is executed, then B, then C, then D. Okay? So in this case, the order is already well defined, so priority doesn't do anything around that. Okay? So how do we order between priority ordered interceptor and actual add interceptors? We'll see that in a minute. But before that, if we want to, for some reason, exclude the interceptors of the class level, you can use the exclude class interceptors that will make the method 2 to only be intercepted by interceptor C and later interceptor D. Okay? There is also exclude default interceptors that disable the default interceptor you define in your, I guess, jbjars.xml and beans.xml, the CDI one. So what are the common rules? The common rules are complex because they are different competing ordering techniques. But what I do recommend, and that what the group really recommends, is for you to pick one and stick to it. Personally, I find this approach a bit nasty because you explicitly have the interceptor class inside your business objects, and I don't like it very much. So I do use the add priority approach. But anyway, we had to define some kind of global ordering rules so that your application actually do what you expect them to do. So the container actually first call all the interceptors that are defined with the add interceptors annotation explicitly on your bin. Once all of them has been executed, we go to the interceptor binding annotation. So if there is an interceptor binding annotation somewhere on the class, we will use those interceptors, and we do use the add priority ordering to order this subset of interceptors. Okay? And finally, if your method actually has interceptor method, so only for the method, when you put the actual interceptor around invoke logic inside your component, which again, I don't recommend, I found that a bit ugly. These will be the last executed. And finally, of course, we go and execute the method or the constructor, right? And then we go back to the interceptor stack. So these rules are complex, but in some ways, you need to forget about it. You choose the strategy you like, let's say add priority, and you use that everywhere. That would be much easier. Another feature that has been added was around the notion of trying to simplify the life of interceptor implementers. If you look at around invoke and around timeout, which is an interceptor of a method that could timeout, I guess I sort of remember forgot the detail here. The signature is simple. Invocation context.proceed actually can potentially throws an exception, so it declares throws exceptions. So because monitor actually also throws exceptions, your code is somewhat fluid and flat, right? So it's easy to understand. But if you use a lifecycle interceptor, it's a bit different. A lifecycle callback, it's a bit different because in theory, a lifecycle callback cannot throw an actual exception. They can throw a runtime exception if they want to, but they cannot throw a checked exception. So the signature that was enforced by Java E6, I believe, was to really force you to say it's a public void. The name of my methods, I'm receiving invocation context, and I don't throw any exception. And the problem with that is when you call invocation context.proceed, you need to wrap that into a try-catch, and the code feels a bit ugly, right? Plus, it's totally useless wrapping here. So what the expert group has done is to say, well, let's relax a bit this rule and say that those kind of methods can actually return an object, even if it doesn't mean anything to them, and can declare throws exception even if it should not throw an exception. So what's happening here, I do declare those stuff, and all of a sudden my code that was a lot of boilerplate around the core part of it is actually much simpler. And the other benefit is that this method could be shared between some lifecycle callbacks and actual method interceptors. Good things. So that's it about the features that actually bin validation directly or very closely uses and really influenced, while actually forced on them. Let's talk about something else, which is looking at the EJB services as conceptual services and try and see if we can reuse them into other Java EE bins, generally speaking. It's a bit of a shame to have to use an EJB just for the transactions, for example, because EJB also come with a lot of additional stacks like security, I guess potentially remoting and stuff like that. So it would be nice to be able to say that any bin in Java EE is transactional without it being an actual EJB. You can do that now because the interceptor specification also has kind of stolen the notion of transactional services to EJB. But it's a bit different in the sense that by default a bin is not transactional, but if you add a @transactional annotation to it, interceptor binding annotation, then the transaction will be activated. And in this case, the logic will be very similar to EJB container managed transaction, right? So the same logic that you have with a default transaction type, in this case required, the same for EJB as far as I remember. When you basically enter an EJB method, public method, we look, is there a transaction? Yes or no. If there is no transaction, we start a transaction. If there is already a transaction, we join that transaction. You can change that semantic with a transaction type, like requires new, which would force a new transaction to be created regardless, and there is additional, a bit less useful ones. So it's really the same as EJB transactions, except they are not enabled by default, right? And also you can define how the method behaves when an exception happens. We'll see that in an example that's actually much easier. And transactional is actually an interceptor binding annotation. It's the same way we did bin validation, the same way you can use an interceptor binding annotation. So it's an interceptor that actually started transaction and so on, and the interceptor binding annotation is @transactional. and it can be applied to a class or a method of a CDI bin. We don't let you use the transactional interception of this generic one with EJBs, because EJB already have transaction enabled by default. So that would have made the rules quite nasty. So it's better to say don't do that and then forget about it. And it turned out that the priority is quite early in the game. We really want the transaction to happen very early. So what we do is platform before plus 200, so at 1/5 of the actual range. I don't remember if security happens before or after transaction. I guess I would have met security before, but maybe it's a bit after. Anyway, it's the same kind of logic. So that works for the, here is the example. I did forget. So this is a CDI bin with request scope. We marked it as add transactional, just like, very much like an EJB. We inject some data source, which is transactional, hopefully. And when I call the get method of account, what happens is, if there is no transaction, a transaction is started, and then we call the method. If there is already a transaction, then we join it, and then we carry on. By the way, it is a good thing to have a transaction and that does only reads. It's not slow, it's not nothing like that. It's just a urban myth. So don't try to optimize your database call by going out of transaction for some stupid wacko reasons. But I digress. The second method is interesting because we have overridden the default settings here. First of all, we require a new transaction even if an existing transaction has been started. So if an existing transaction is there, we just basically make it, we suspend it. Then we go and execute the method with a new transaction, and then we resume the transaction once we're done. And you can declare what should happen when some kind of exception happens. So if there is an SQL exception, let's roll back automatically. Except if it's SQL warning, which the name doesn't actually show it, but it's a subclass of SQL exception that is not quite an exception because it's a warning, but then I guess the backward compatibility of JDBC required to do some kind of funky stuff here. Clear? So what about the other features like non-transactional services? I did mention security a couple of times. Can I also use them in a separate way? Well, unfortunately not yet, but that's definitely the plan, except it's all about priorities. So try and push, basically try and push Oracle and us, I guess, to do that, to really split apart EJB, make it die, and really keep the good part of it, which is all of the services, and makes them aspects of your beans in the general sense of it, okay? So it's not a given, it's really the plan if there is enough resources, so go and petition for it. Send emails, tweets, whatever works. Snail mail, anything. So that's a lot of slides. So what I wanted to show you is the actual code we use in Hibernate Validator to which is actually the interceptor for bin validation in Whitefly and happens to be the same for Glassfish, actually. Shameless plug, if you want to know more stuff about bin validation, I highly recommend you to go to binvalidation.org. If you see a typo, you can fork the GitHub repo and fix it and send a pull request. Same for the RI, same for the TCK, same for the specification. So please, please work for me. That would be the message, I guess. But seriously, you got a lot of information: the spec itself, the roadmap, how to contribute, the the license and things like that. So this is the code of this is the interceptor that we have implemented as part of Hibernate Validator, which is both the reference implementation of bin validation, the spec, which is used by Whitefly, Glassfish, very likely WebLogic, but I haven't looked. Not sure about WebSphere. It's also the best, but don't take my word for it, test. So what happens here is I've got an interceptor, which is a regular class, except it's annotated with @interceptor, and an actual interceptor binding annotation, which is actually a private one. We don't actually display it to you, okay? It's in an internal package of us. It's a literal, interceptor binding annotation that is supported on method, type, and constructor. And we define the priority. We say, hey, we want to be as late as possible unless somebody is really, really in a non-hurry. I can use injection, so I will use the actual validator service to do the actual bin validation execution. But the core of it for this method is the add_around_invoke. The method that is marked as add_around_invoke, right? I receive an invocation context that contains the parameters, the methods, and I can do a lot of things with that. So when you go from bin validation validator interface, all of the API is really for like application-centric usage, but executable is really for interceptor technology. So we put all the interceptor-related, the method validation-related methods into a sub-interface called, executable validator or something like that. So you do validator.for executables, you get this actual interface, and I will first go and validate the parameters. I get the actual instance that I'm that would be empty in this case. Well, yeah, it would be, no, that's a method, sorry. So I've got the object I'm executing a method on, I've got the actual method, and I've got the parameters, which is an object array. And then bin validation gives me back the list of constraint violations. There can be none of it, which would be nice. It means the client actually has been a nice guy and didn't try to break your methods. But if it was a nice guy, it was not a nice guy, then we create a constraint violation exception that literally get the list of constraint violations. So all of the errors you found in the parameters will be exposed back to your application and potentially to the UI. Then I call proceed, which means I'm calling the next interceptor, which I'm probably the last. So that would actually call the method, do whatever the method has to do, potentially return a value, and that value might actually also be constrained, right? Remember the @not null for the list of person above a certain age? That's how I do it. Well, actually the code could be somewhat optimized. I'm sure the compiler can do that for us, but anyway. It does not? Okay. So I guess we should fix that. So validate return value here will validate the constraints that are on the return value. If there is no constraint on the return value, which is the actual, on the method, then we just ignore it. It's almost a no-op. But if there is one, then we got the object we execute the method on, the actual method, and the result. And if there is no violation, life is good, we return the result. If there is a violation, we raise a constraint violation exception. The code is extremely similar for AroundConstruct, which will validate constructors, except we call validate constructor parameters, and we accept constructors instead of methods. Anything else different? Yes, something else is different here is that, A, we don't have any target object because we haven't created it yet. So that makes sense. But we keep and proceed, and the target is actually part of invocation context.getTarget, and this getter is actually populated after the last .proceed call. Then, of course, we go validate constructor return value, and if everything is fine, we do nothing, and then the new instance will be provided to you. Okay? The rest of the code is not really interesting. As that in mind, yeah, let's open up for questions. If you have any questions about interceptors, bin validation, and potentially some other Java EE related spec, I will happily try to answer them. Come on. Any question? I can't really quite see you, so you could shout. No? All right. Well, I guess thanks for attending. And if you have any private question, I guess you can come down to me, and we can definitely have a chat. Thank you, everyone.